Alright, and this is our final topic of chapter 10. We're going to talk about graphing simple rational equations. So our goal, our objective here is to graph simple rational equations. Well, what does that look like? Today we're going to look at functions that look like this: y equals ax plus b over cx plus d. That is called a hyperbola. So some people think like, oh, hey, look, there's a bowl here, there's a bowl here. I got hyperbolas. I don't know. But hyperbolas are what they call. They look like this or this. And then we're going to see some shifts on those as well. So what is a hyperbola? Well, really, it is two branches or curves separated by asymptotes. Well, asymptotes are parts of a graph that graphs approach but never touch. There's no set rule for these, so that's why we're going to go through how to graph them. The location of them is determined by those asymptotes that we have. So again, first, we're going to talk about this thing called a vertical asymptote. So the vertical asymptote of a function is by setting the denominator equal to 0 and solve. So we've done that in the past, setting it equal and solving. Then we need to find a horizontal asymptote. Well, that's y equals a over c. So we're going to take this a here and c. So a over c, and that's y equals. Then, after we do that, we need to create a table using 4 points to the left and the right of the vertical asymptote. So we're going to come back to that vertical asymptote. Finally, here's just kind of our little, oh hey, when you're graphing, just be careful how you type. You need to make sure that you use separate parentheses around the numerator and the denominator. Alright, so let's go through, let's do an example. You'll do fine. So first thing it's asking is vertical asymptote. Well, it's like, oh hey, Mr. Millikan, I have no clue what I'm doing. Vertical asymptote, set denominator equal to 0 and solve. Oh hey, well look, here's my denominator. So we're trying to find vertical here. So take your x plus 3, or 3x, minus 3 equal to 0. Add 3, add 3. 3x equals 3. Divide by 3, divide by 3. X equals 1. So what am I going to do with that x equals 1? I'm going to set it in the middle of the table, x equals 1, and I actually am not going to graph that point because it never touches it. And when we go into a graph here, we'll see that. All right, domain. Well, x cannot equal 1. So your domain is going to start at negative infinity. We're going to go to 1, and we're going to stop at 1 and pick up. How do I graph an asymptote? Well, go to x equals 1, so 1. And then you're going to draw a dotted line straight up. So I got my asymptote, x equals 1. Now let's find the horizontal asymptote. Well, Mr. Millikan, I have no clue what a horizontal asymptote is. Horizontal, go back, y equals, so first of all that tells you, hey, I need a y equals a over c. Well, what's a over c? I've got 6 over 3. So y equals 6 over 3, which is really just 2. So y equals 2. Go to 2 on the y-axis, and we're going to draw our horizontal asymptote through that. Alright, range. Well, range, it cannot hit that line. So I need negative infinity, stopping at 2, pick up at 2, and go to infinity. Well, the y-intercept, that should be the easy one. 0, put 0 in the equation. Well, 0, 0, that's negative 3 over negative 3, which is positive 1. Alright, so again, here's where I need to create my table using 4 points to the left and right of the vertical asymptote. So I put 1 in here. I need to go to the right of it. So 2, 3, 4, 5. I need to go to the left. 0, negative 1, negative 2, negative 3. Now, if you want, you can go ahead and do that. But I'm going to say, hey, let's take our calculator and do this. So again, be careful how you type. Separate parentheses. So parentheses, 6x minus 3, end. Divide, parentheses, 3x minus 3, end parentheses. You can hit the graph to say, oh, hey, what does this look like? Well, we got a branch going down and a branch going up. Well, that kind of looks like our parabola over here, which is shifted a little. Well, yeah, let's put in our table. Second table, so second graph. And I started at -3, so I'm going to arrow to -3, and I've got 1.75. So 1.75. Then I've got 1.67, 1.5, 1. And again, you see that little error. So that's why I'm not using this, because it can't hit it. So error. 3, 2.5, 2.33. So 2.3 is fine enough, and 2.25. Alright, so now we just got to plot this to get our graph. -3, we're going to go to 1.75, so we're up here. -2, 1.6, 1.5, 0, 1, and then we've got 0, we got an error. So we're kind of curving towards here. And as you saw on that graph, we're going to approach the asymptotes, but not actually touch them. So I got one branch, 2, 3, so I need 2, 3, 4, 2.3, so we're a little bit above, and then I'm approaching here. So again, I need to approach the asymptote, don't touch it, approach the asymptote, and go up. So that's our graph. We want kind of a rough sketch to these. Alright, let's go through 2 more examples, and then you can try some. Alright, so we got vertical asymptote. Denominator equal to 0. So 2x minus 4 equals 0, plus 4, plus 4. 2x equals 4, divide by 2, divide by 2, x equals 2. So x equals 2. Graph it. X equals 2. Go to 2. Alright. Again, 2 is going to go in the middle of the table, so I can put points to the left, and I'm not going to actually use 2, and we'll see that error later. Everything but the asymptote. x2, union 2, infinity. My horizontal asymptote, that's y equals my 8 over 2. So 8 over 2, which is 4. Y equals, go to 4, and draw a horizontal line through 4. Again, my range cannot be that, so negative infinity to 4, union 4 to infinity. Y-intercept, put 0 in, you get negative 1/4, or 0.25, negative 0.25. Alright, I'm ready for a table. So I need, let's see, 1, 2, I got 3, 4, 5, 6. So again, I just go integers. 2 minus 1 is 1. 0, negative 1, negative 2. And here we go, we got to clear out our function. So what did we use here? Parentheses 8x plus 1 divided by parentheses 2x minus 4. I'm going to go straight to the table. I start at -2, so I need -2, and I'm at 1.875. So 1.87, 1.16, negative 0.25, again, negative 1/4, negative 4.5, error, so again, you can write error in if you want, 12.5, 8.25, 6.83, 6.8, and 6.12. So again, if you want to go to the graph and kind of get a rough estimate here, that's always a good thing to say, hey, am I doing this right? So 3, 12.5, that's way up there. But I could probably plot 4, 8.5-ish. So for 8.5, I can plot 5, 6.8. So 5, 6.8, we're around here. 6, 6.2. So again, we see that this curve is kind of starting to approach the asymptotes. 1, negative 4.5, so negative 4.5. I can do 0.25, so that's 1/4. 3, negative 1, slightly over 1, and it's starting to kind of curve here. We can see it's approaching that asymptote. Again, your graph is not actually going to show you the asymptotes, so you need to say like, oh hey, you need to get those approximate, plot a few of your points from your table to get that. Alright, so let's try one more together before I have you break. Alright, so asymptote. We're starting with the denominator, so 2x plus 3 equals 0. Minus 3, minus 3. 2x equals negative 3. Fraction. X equals negative 3 halves. Fractions are going to happen, so we got to kind of discuss, like, well, put your fraction in the middle. Again, we're not going to actually plot that. Negative 3 halves. You should know that that's negative 1.5. So in the middle of negative 1 and negative 2 is where you're going to plot that asymptote. Right? We can't have that, so negative infinity, negative 3 halves, union negative 3 halves to positive infinity. Horizontal asymptote. Again, ratio. Oh no, another fraction. Y equals 5 halves. Well, that's 2 and a half. So we got to go up 2 and halfway between. And we're going to draw our asymptote in there. Range, everything but that, so negative infinity, 5 halves, union, 5 halves, to infinity. Finally, y-intercept 0, plug in 0, you get 2/3. Alright, ready to graph? Oh, we didn't pick points. We had negative 3 halves in here. Well, if I want to go more positive than that, what's the next whole number? Positive. Well, negative 1. So try negative 1. Then you have 0, 1, 2. Or go by halves. Either way, you're going to get there. Well, negative 3, what's the next whole number? It's going to be negative 2. So negative 2, negative 3, negative 4, negative 5. Alright, go to y equals, let's pop it in there. 5x plus 2 divided by 2x plus 3. Alright, and again, I'm just going to look at the graph. So I know my branch needs to be in here, and I need a branch down here, but I need a little bit more exact than that. So, need to go up 1. 3.2, so 3.2, negative 5, 3.2, we're about in there. Negative 4, 3.6, so negative 4, 3.6, we're going up a little bit. 4.3, so negative 3, 4.3, we're going up some more. Negative 2, 8. Well, hey, we kind of see, oh, we're going up. So again, I can kind of get that general shape in there. That's all I'm asking for, is that general shape. Alright, now notice there's no error in here. That's because the point negative 3 halves is not in here. So you got to remember that that's going to be that error. Negative 1, negative 3. That's a nice point to plot. Negative 1, negative 3. 0.66. And we spoke too soon. 0. 0.66. 2/3. 1.4. So 1, 1.4. And 1.7. So 2, 1.7. Again, we're approaching this asymptote, but not going to cross it. Approaching the vertical, not going to cross it. Alright. Here you go. This example and this example, both of those you try. Which means that you should have no problem doing these, because one, we just went through 3 whole examples. And you could use your calculator. So no excuses. Get those done, bring them to class. We will talk about them.